Hi, welcome to the class. Today we will continue our discussion on the Bohr's theory, which before this we had already done about, we have studied about energy. Today we will study about origin of spectral lines. So what we will study in origin of spectral lines is that energy we have studied E is equals to minus m z square E4 upon h square n square. Now which spectral lines we are talking about is this, that as you know that, so this is N2 and this is lower orbit. Energy at the higher orbit is E2, energy at the lower orbit is E1. When the electron will jump back from the higher orbit to the lower orbit, it will emit some energy in the form of a photon, and the energy of the photon will be h nu, right? So E2 minus E1 is equals to h nu. Now if I use this equation and put these values, what I will do, and obviously we are talking about a spectral line for hydrogen specifically, so Z will be 1 here. Okay, let us just do the modify, just put up the values rather than giving it like for hydrogen or helium. So minus m I am not putting the value here, I am just writing N2 square. N1 square. Now I have to subtract E2 minus E1. So you know that if I subtract it, it will become plus because this minus is already there. So h nu is equals to plus I have done because this minus plus. Now I am writing this here and then taking the negative equation that side. So it will be h nu. Rest of the things you see that it will come common. One upon N1 square minus 1 upon N2 square, right? I'm going to take this h down there. Now nu frequency is equals to c by lambda. See, I'm bringing it here. This is the expression. Now I'm going to introduce one constant here, and the value constant would be R, which is Rydberg's constant, and this value is R is equals to me4 upon 8 epsilon naught I think this is, guys, I forgot this is square here, it will be square. Eight epsilon naught square. Cube C. Now, if I write, the value will be 1.1 into 10 to the power 7 per meter. This is the value. Now, if I write the equation 1 by lambda is equals to R, so I think here Z square is left, and me Z Rz square upon C okay, I have taken C, so this is the expression, right? Now let us formulate this for hydrogen. For hydrogen atom, and we already know that for hydrogen atom the expression for the energy right, so this is there. Now guys, let me just give you one question based on this. And the question is, okay, so basically in this question, the ionization potential energy of hydrogen atom. So now we are talking about hydrogen atom, so this N is equals to 1, we are talking about the ground state. So remove this. So energy for hydrogen atom 1, put this 1 here, it is given minus 13.6 eV. Now in the question they are saying that, and we have to calculate the energy when an electron falls from the third orbit to the second orbit. So n is equals to 3, 2, it is falling to n is equals to 2. We have to find the energy. So one, you can use this E3 is equals to minus 13.6 upon 3 square. This is 1. 2 minus 13.6 upon 2 square EV, and if you are calculating the difference in the energy E2 minus E1, after calculating that you can easily do that, right? So that would be the calculation of energy. Now similarly one question is there where this expression is given, En is equals to this is given already. An electron is jumped from n is equals to 2 to n is equals to 1. This is a separate question. So I shall tell you the answer of this question. The answer of this question would be it is 1.9 E. The difference of these two, you can calculate that. E3 minus E2. Now in this question guys, this equation is given, N2 and 1 is given, and they are asking you to calculate the wavelength. Now how do you do that? So obviously E3 minus E2 minus E1 you can calculate h nu. This you can calculate putting those value of n there like we had done here. And instead of this nu you will write hc by lambda. So you know the value of c and lambda. C is the speed of light and h is the Planck's constant, and you can calculate the lambda. This is how it can be done, right? So I hope that you understood today's topic. Thank you.